Hello guys, welcome again to our ongoing series of Irodov's numerical problems of physics. Here in this video, we will be taking the third numerical problem of Irodov, which is the car starts moving rectilinearly, first with acceleration w is equal to 5.0 meter per second square, then uniformly and finally decelerating at the same rate w comes to a stop. The total time of motion equals t is equal to 25 seconds. The average velocity during that time is equal to v is equal to 72 km per hour. How long does the car move uniformly? So in the problem it is said that car is moving rectilinearly, means car is moving along a straight line. So in place of position time graph we will represent the motion of car with xt graph, which is shown here. On y-axis we represent x, which is in meter, and on x-axis we represent time, which is in second. Car starts from rest, so initial velocity of car is equal to 0. It moves first with the acceleration w is equal to 5.0 meter per second square. Because car is accelerating initially, so it picks up speed first, then uniformly, then car moves uniformly, and finally decelerating at the same rate w comes to a stop. Then finally it decelerates and comes to stop. This is the point where it stops. The total time of motion equals t is equal to 25 seconds. We are given with total time of motion, which is shown here, which is 25 seconds. The average velocity during that time is equal to 72 km per hour. We are also given with average velocity, which is in kilometer per hour, because we are representing displacement in meter and time in second. So we will represent the average velocity in meter per second. So average velocity is average velocity of car 72 km per hour. We will convert it into meter per second. To do this, we multiply it with 5 by 18. 18 4 just 72. So we will get 20 meter per second. So the average velocity of car in meter per second is 20. How long does the car move uniformly? We have to find out the time duration during which it moves uniformly. So in the problem we are given with average velocity and total time of motion. So we can find out the total displacement during the whole motion, which is equal to the product of average velocity and total time of motion. So total displacement during the whole motion is equal to average velocity, which we will take in meter per second, into total time. Average velocity is 20 meter per second and total time is 25 seconds. So it will come out to be 500 meter. So total displacement here will be 500 meter. Now consider the time duration during which car is accelerating is t1. Also the duration during which it is deaccelerating is t2. We can see from here that t1 is equal to t2. Let's see how. Also consider that velocity acquired by the car after acceleration is v. And car is moving with same velocity during uniform motion. So here also velocity will be equal to v. And finally car stops. So here velocity will be equal to 0. We know the equation of motion, which is v final is equal to v initial plus at. Now during acceleration, final velocity is equal to v, initial velocity is equal to 0, acceleration here is equal to w, which is equal to 5 meter per second square, and time during acceleration is t1. So from equation of motion, v final v is equal to initial velocity 0 plus w into t1. From here, t1 is equal to v upon w. Putting the value of w, we can find out the t1, which is v upon 5 second. Also during deceleration, final velocity of car is 0, initial velocity of car is v. Here acceleration is equal to minus w because car is decelerating here. So this is minus 5 meter per second square, and time during deceleration is t2. So from equation of motion, v final 0 is equal to v initial v minus w into t2. Here we taking the w with negative sign. So from here t2 is equal to v upon w or v upon 5 second. So from here we can see that t1 is equal to t2. So far we have seen that t1 is equal to t2. Then what will be the time duration of uniform motion? This will be 25 minus 2t1. 25 minus 2t1. Now if we have the value of t1, we can find out the value of time duration of uniform motion. So what we do, we find the total displacement during whole motion in terms of t1. Then we put it equal to 500 meter to find out t1. Once we find t1, then we can find out the time duration of uniform motion. To find the total displacement, we have to find out the displacement during acceleration, displacement during uniform motion, and displacement during deceleration. Then we add the three displacement to find the total displacement, and also we will see that displacement during acceleration is equal to displacement during deceleration. So let's do it. Now from equation of motion, we have displacement is equal to initial velocity into time plus half into acceleration into time square. So this is the equation of motion of displacement in terms of initial velocity and acceleration. Now we'll find out the displacement during acceleration. During acceleration, let us say we denote the displacement by S1. So S1 is the displacement during acceleration. Also during acceleration, initial velocity is 0. Acceleration is W, which is equal to 5 meter per second square. Also time during acceleration is T1. So S1 is equal to initial velocity into time, which is T1, plus half into W. W here is acceleration. So W into T1 square. So S1 will come out to be half into W into T1 square. Putting the value of W here, we will get S1 is equal to 5 by 2 T1 square. So this is the displacement during acceleration. Now we'll find out the displacement during deceleration. During deceleration, let us say we denote the displacement by S2. We will see here that S2 is equal to S1. That is, displacement during deceleration is equal to displacement during acceleration. So during deceleration, initial velocity is v, acceleration here is minus w. Here negative sign is taken because car is decelerating here. So it is minus 5 meter per second square. Time during deceleration is t2. So s2 is equal to initial velocity v into t2 plus half. Here acceleration is minus w into t2 square. Also we have proved that t2 is equal to t1. So we can put in place of t2 t1 here. So s2 is equal to v into t1 plus half into minus w into t1 square. Also we have shown that t1 is equal to v upon w, where we have calculated time of acceleration and we have shown that time of acceleration is equal to time of deceleration. There we have shown that t1 is equal to v upon w. So we will put the value of v in terms of w and t1, which is equal to w into t1. So S2 is equal to W into T1 into T1, minus sign taken here, minus half into W into T1 square, which again come out to be half into W into T1 square. Putting the value of W here, we will get 5 upon 2 into T1 square. So from here we can see that S2 is equal to S1. That is, displacement during deceleration and acceleration is same. Now we'll find out the displacement during uniform motion. Let us see, denote it by S3. During uniform motion, displacement is equal to S3. Now displacement during uniform motion is equal to velocity into time. So S3 will be equal to velocity during uniform motion into time of uniform motion. So this is the formula for displacement during uniform motion. From here, we can see that time of uniform motion is 25 minus 2t1 and velocity during uniform motion is v. So let us put these values here. Then S3 will be equal to v into 25 minus 2t1. Putting the value of v from here, that is w into t1. So S3 will come out to be w into t1 to 25 minus 2t1. Putting the value of w here, we will get S3 is equal to 5 into t1 minus 25 minus 2t1. Adding the three displacement, we will get the total displacement. So total displacement is equal to S1 plus S2 plus S3. S1 we have calculated is 5 by 2 T1 square. Also S2 is equal to S1, which is equal to 5 by 2 T1 square, and S3 here is 5 into T1 into 25 minus 2 T1. Also total displacement is 500 meter. We have already shown. You can see from here total displacement is 500 meter. We will put this total displacement in terms of T1 is equal to 500 meter. So 5 by 2 T1 square plus 5 by 2 T1 square plus 5 into T1 into 25 minus 2 T1 is equal to 500. So this is the equation in terms of T1. Solving this, we will get 5 T1 square plus multiplying 5 T1 inside the bracket, we will get 125 T1 minus 10 T1 square is equal to 500. So this is minus 5 T1 square plus 125 T1 is equal to 500. So this will come out to be 5 T1 square minus 125 T1 plus 500 is equal to 0. So T1 square minus 25 T1 plus 100 is equal to 0. Taking 5 common here, we will get this equation. Solving this, we will get T1 is equal to 20 or 5. We cannot take T1 is equal to 20 because if T1 is equal to 20, then time duration of uniform motion, that is 25 minus 2 T1 will become 25 minus 2 into 20, which comes out to be minus 15 seconds, which come out to be negative. It cannot be negative, so T1 cannot be equal to 20. So T1 is equal to 5 seconds. So time duration of uniform motion uniform motion which we have to calculate in this question will come out to be 25 minus 2T1, which is equal to 25 minus 10 is equal to 15 seconds. So this is the answer. Next question we will take in the next video. Thank you.